These are actually really simple. They go right along with the sum and difference identities. So we're actually going to derive them ourselves. That means come up with them from information that we already know. So you can see at the top what we're talking about, double angles, meaning 2 theta, doubling the angle. Theta being the angle, so this is 2 theta, cosine 2 theta, or tangent 2 theta. So we'll do sine first. So sine 2 theta is the same thing as saying sine of theta plus theta. Right? Because theta plus theta would be 2 theta. So now we're going to use the sine sum identity that we were using Friday and yesterday. So sine of theta cosine theta plus cosine theta sine theta. Now remember, multiplication is commutative. So even though one of them has sine first and cosine second, the second one, it's the same thing. So they are like terms, which means that I can actually add them together. So I have 2 of these things. So actually we're adding them. Not multiplying. 2 sine theta cosine theta. And that's it. That's the identity. So now anytime you see sine of 2 theta, you could replace it with this, or vice versa, whichever one helps you.
They're kind of just like expanding it, kind of, right?
No, that's what anybody have done? She did distribute, she distributed it to the type. I did this on you. Go for it.
Alright, so we're going to do the same thing for cosine.
Okay, one question.
Yeah.
Where did the cosine come from? Like
From the, I don't have mine right here, I don't think, but, well, I guess I do. Hold on, under calculus. Here. From the sum identity. Think I got their sum identity? Wait, here's mine. Right here. From the sine sum identities. See, sine of a plus b equals all of this. So that's what I use. Yeah, it's from Friday.
Even if there's not a cosine in the first place,
Right.
it's still a cosine.
Just like tangent doesn't have a cosine in it to begin with, but we replace it with sine over cosine because it's the same thing. That's exactly what this is.
Okay.
Sine of a plus b is the same thing as all of this. So that's what I used on this one. Sine of 2 things is the same as sine cosine plus cosine sine of that. And then cosine, we're going to use the cosine sum identity. So cosine of 2 theta is the same thing as cosine theta plus theta. So I happen to have them memorized, but if you don't, you can look for a little while longer before you memorize them. There's the cosine sum identity. Cosine a plus b, mine says theta plus theta, but cosines are grouped together, and remember, these are the ones with the backwards sign. If it's a plus here, it's a minus in the middle. So cosines are grouped. So it's going to be cosine theta, minus, now the sines are grouped, sine theta, sine theta. Well, what is cosine theta, cosine theta?
Cosine theta squared. Or
Cosine squared theta, yeah. And same thing for sine. Okay, so that is the identity. Now, they gave me a much bigger box for cosine 2 theta. That's because there is more than, I can continue to break this down a different way because of the Pythagorean identity. See, now that I have something squared, I could take that out and replace it with something else. Cosine squared theta is the same thing as 1 minus sine squared theta. So I can take cosine squared theta out and put 1 minus sine squared theta in its place. And then that simplifies to 1 minus 2 sine squared theta. So that could also be my cosine double angle identity.
That doesn't matter.
Doesn't matter. It depends on which one's more useful to you. And we'll use them here in a minute and you'll see. And then I can also go back to this, and instead of taking cosine out, I can take sine out. If I take sine out, what am I going to replace it with?
1 minus cosine.
1 minus cosine squared theta. So that would be, so the cosine squared theta would be the same, minus 1 minus sine squared theta. Now in this one you have to distribute the negative. So I'm going to take a line to do that so I don't lose anybody. So that'd be minus 1 plus sine squared theta, because I'm distributing that negative. If I had a- Okay, so that means, wait, I replaced the wrong,
Cosine
dang
squared.
it!
Yeah.
Cosine squared.
Cosine squared. Okay, y'all knew what I meant. See, and y'all corrected me, that's good. That means you kind of know what's going on. Okay, so that means I have a cosine squared theta and a cosine squared theta, so I gotta add those together. So I have 2 cosine squared thetas minus 1.
So either of these answers are right?
Any of them will work. And they will all work every time. It's just that sometimes you can make your life a little easier or the process shorter if you choose the right one.
So all
You'll
you,
see in a minute.
all you did in the last one was just move the cosine squared theta over.
I grouped these two together, because there are 2 of them. Okay, so now let's do the same thing for tangent. So tangent to theta is the same thing as tangent theta plus theta. So our tangent sum identity, now that's the one we did yesterday, so you may not know it quite as well yet. Tangent sum identity is right here. So it's tangent A plus tangent B, so mine's going to be tangent theta plus tangent theta, over 1 minus tangent theta, tangent theta. So tangent theta plus tangent theta, 1 minus tangent theta, tangent theta. So on top I get to add those together. There are 2 of them. So it's 2 tangent theta over 1 minus tangent squared theta. So that's your tangent identity. Okay, so now we will use them. Okay, first thing, this stuff is taking us back to old stuff. In A, problem A. Okay, so at the top it says suppose sine theta equals negative 3/5. Tangent is greater than 0. Answer the following questions about theta. In which quadrant does theta terminate? And explain your reasoning. So let's just go step by step to explain our reasoning. Sine is negative. So I'm going to write sine of theta is less than 0. Is everybody okay?
Yes.
What quadrants can that happen in? In 3 and 4? Tangent is greater than 0 in 1 and 3. So, theta is in 3. Everybody remember doing this?
Yes.
Doesn't that feel easy now that we've done all this other stuff? Okay. So now it says draw the angle theta and label the reference triangle. So we know it's in quadrant 3, so there it is. Remember the symbol always goes between the terminal side and the x-axis, so it would be right there. Draw a triangle. Sine is negative 3 over 5. So that would be opposite over hypotenuse. So 3 and 5, so that makes that 4. Everybody good?
Was it negative?
Negative 3 and negative 4. 5 will always, the hypotenuse is always positive because you get it by squaring, so it has to be positive. Everybody's okay? Alright. Now it tells us to order sine 2 theta, cosine 2 theta, and tangent 2 theta from least to greatest. So we're actually going to have to use our double angle identities and find the actual values, and then we'll put them in order. It's pretty easy. Okay, so sine is the easy one. Sine 2 theta is, now you don't know yet, you don't, I'm sure, because we just did it. It's right there. 2 sine theta, cosine theta. So that's going to be 2 times sine theta, which they told us was negative 3/5. Cosine theta, I'm going to go to my triangle and I'm going to get it off. So Katoa, so it's adjacent over hypotenuse, so it's negative 4/5. Which multiplies straight across and you get 24/5. 25/, sorry. Any questions so far?
They just assume that 2's over 1.
Do what?
Just assume 2's over 1.
Yep, always. All whole numbers are understood to be over 1. Okay, so cosine of 2 theta. Now, we have 3 choices. It doesn't matter which one you use, you're going to get the same answer either way. So let's look at them and see what do we think will be easiest, or which one do you want to use? Does it matter? Who cares? What do you care?
Cosine theta.
You want to use
Cosine.
this one?
Yes.
Okay, cosine squared theta minus sine squared theta. Okay, we already know what they both are because we pulled them off just a second ago. So it's negative 4/5 squared minus negative 3/5 squared. So that's 16/25 minus 9/25, which is 17/25. You would have gotten the same answer if you'd have chosen to use one of the others. Doesn't matter. Everybody okay? From this triangle. Alright, now tangent to theta. Our identity is 2 tan theta over 1 minus tangent squared theta. Okay, so now I need tangent. So I go up to my triangle and tangent is TOA, opposite over adjacent. So my opposite piece is negative 3, my adjacent piece is negative 4, the negatives become positive, so it's 3/4. So it's 2 times 3/4 over 1 minus 3/4 squared. Is everybody okay?
Yes.
Okay, so the 2 is understood to be over 1. So the top would be actually 6/4. On the bottom, I'm going to do this in several steps so I don't lose anybody. The bottom would be 1 minus 9/16. All I did just then was square this. Okay, so now I need to change that 1 to something with a common denominator, so I should actually subtract on the bottom. So it's going to be 16/16. So I haven't done anything to the top, it's still 6/4. On bottom, if you subtract, you get 7/16. Now what do I need to do? Keep, switch, flip. So keep the 6/4, switch to multiply, 16/7. Make your life easy, 4 goes into 16 4 times, so you get 24/7. Now they asked us to put these in order from least to greatest. Which one is smallest? 17/25. So cosine 2 theta is smallest. And then sine 2 theta. And then tangent. That's the order from least to greatest. Okay, so that's using it if they actually give you values or give you a triangle and you can plug the values in. So down here we're going to use it to verify a trig identity. And I think on this one actually, we probably are going to have to do both sides. And the reason I say that is because none of them are in terms of sine and cosine. And if you look at my identities, all the identities I'm using are in terms of sine and cosine. So I'm probably going to have to do both sides. But let's start with this side because it's the one with the double angle. Now here's the problem. I don't have a cotangent double angle identity. So what do I need to do to cotangent? To what?
Cosine over sine.
Cosine over sine. So this is going to be 2, and instead of cotangent, I'm gonna put my 2 out in the front and put a multiply, okay? So that we're not even really concerned right this minute what the 2 belongs to. It's a constant being multiplied by cotangent. So now I'm going to write cosine 2 theta over sine 2 theta. Is everybody okay?
So at this point, the 2 doesn't belong in.
So at this point, the 2 is just in front. We'll just not worry about it. It takes care of itself in a minute, so you don't really have to worry about it. Okay, now, cosine has those 3 choices, and I'm not really sure what to choose yet. So, because I think I need to fix the left-hand side in order to figure out which one will make it easiest. Now, it doesn't really matter which one you choose. They will all work. But we would like to make our life easier, so let's choose the one that works easiest. And I don't know which one that is yet. So, I'm going to fix this sine thing first, and then we'll worry about cosine. So, I still have the 2 in front. I'm not messing with cosine yet, because I don't know which identity to use. But I can change sine to theta using my identity. Sine 2 theta equals 2 sine theta cosine theta. So, alright, well that 2 that we put out in the front and I said don't worry about, that's a whole number, understood to be over 1. This 2 is clearly in the denominator, so what can I do?
Cancel.
I can cancel those 2. Alright, now at this point, I don't think there's anything else I can do until I figure out what I need to do with cosine. So I need to work on my other side first. So-
make cotangent cosine over sine.
Yes, make cotangent cosine over sine. Minus tangent, which is sine over cosine. Now what?
Cancel.
Common denominator. So the first fraction needs the cosine piece on bottom and on top. And the second fraction needs the sine piece.
So then you just factor.
Okay, so far so good?
Yeah.
Now I have a common denominator, so I can just rewrite that denominator, cosine theta sine theta, and subtract across the top, cosine squared theta minus sine squared theta. Well, we just saw that. Cosine squared theta minus sine squared theta is right here. It equals cosine 2 theta, which is exactly what this equals.
Well.
So, cosine 2 theta over cosine theta sine theta. Now these 2 things are equal.
So does this has nothing to do anymore with like cosine squared theta minus sine squared theta?
It does. It does. They all come from the same place.
Okay. But you wouldn't put 1.
No, because it's not. It's plus.
Oh, okay.
So you're still trying to get the other side to equal.
Equal.
The other side.
So you might do, in just a second, we'll do one that it's all one side. You might do all the left side. You might do all the right side, or you might do a little bit both ways.
So it's the same thing, we're just using different identities.
Now you just got new identities. More identities. And there's more. There's a lot. We're not gonna learn them all. They just learned some of them. We're learning the most common ones. Okay, so this is one where we're just gonna do one side. We're gonna make the left-hand side look like the right-hand side. So, I have sine 2x on top. I'll fix that first by changing it to 2 sine x cosine x. Okay, now I need to fix the cosine identity, but this is the one that has several. And this is the only part I'm changing. So the 1 minus is still there. I'm going to change the cosine 2x. But I need to figure out which thing I'm changing it to. So where are you headed? Cotangent. And what is cotangent?
Cosine over sine.
Cosine over sine. So if I look at my 3 identities, which one do I probably not need? The last one, because it's cosine. I need a sine on bottom in order to get to cotangent. So really, either the top or the second one is going to benefit me the most. Which one do you think we should use?
First one.
I'd use the second one. Because, now, you can get there using the top. It'll just take longer. If you use this one, then you don't have any cosines on the bottom you have to worry about. All you have is sine, which is what we're trying to get to, because we need cotangent. So I'm going to use the one in the middle, 1 minus 2 sine squared theta.
Let's do that.
Do you have to distribute the negative
Okay, so this replaced the pink. So that's why the 1 minus is still there. Now, I have to distribute that negative. So I'm going to write that out so I don't lose anybody. Alright, what happens to 1 minus 1? So now I have 2 sine x cosine x over 2 sine squared x. What happens to your 2's? They cancel, and one of your sines. So you're left with cosine x over sine x, which is cotangent. Wasn't too bad, was it? Okay, now the next one I'm gonna be honest. It's not fun. Okay, but these show up actually quite a bit, so. Okay, so they give me sine 4x and I don't have anything. Now, this is one that is different. You're not gonna take the complicated side and make it look like the small side. We're gonna do the reverse. Because this is a double angle identity, sort of. It's 4x and we don't know one for 4x, but we do know one for 2x. So I'm gonna do sine of 4x is the same thing as sine 2x plus 2x. Now, you will probably see one like this again. It might not be 4, it might be 3, in which case you would do sine 2x plus x. So, 4x plus 2x. Yes? Yeah. Okay. And into the office. Okay, so now we're going to use the sine sum identity. So that's this one. So sine and cosine, sine and cosine.
How do you know which one to pick, like top and bottom? That's what.
Oh, because it's a plus.
Just,
So what I have is a plus, because I had to add them to get 4.
So if it was
So you-
negative 4x, then you would.
Actually, no. But if it was, not on this one.
Okay.
But on the homework, when you were trying to get, let's say you were trying to get angle 15 degrees, you would do 45 minus 30.
see, cause
So you would use the
then,
minus
Because
one.
then we did negative 15, so it's negative 45 plus 30.
Exactly. And I would use the plus one. Okay. So this is going to be sine 2x cosine 2x plus, I'm going to go ahead and, oh, no I'm not. I don't want to confuse anybody. Cosine 2x sine 2x. Okay, now, addition and multiplication are commutative. So does everybody agree that these two, even though cosine is listed first here and
Yes.
sine is, they're the same, right?
Right.
So I have 2 of them. So I can put them together and make it 2 sine 2x cosine 2x. Now, if it helps you to keep it straight, you can put parentheses on your little arguments that go with your trig functions. Okay, so now 2x is a double angle. So I'm gonna do sine first because that's the easy one. I'm gonna fix this. The 2 is just a coefficient in front. So I'm gonna leave the 2. I'm fixing just the sine right now. Using 2 sine theta cosine theta, but it's gonna be x. So 2 sine x cosine x. Okay, so this replaced that. Everybody okay? Alright, so now we've got to replace cosine of 2x. Now this is where a decision comes in, because I've got choices. So look at where you're headed. I am trying to get to this craziness.
So you.
So which one of these will probably get me there easier?
1 minus 2.
I need a cosine
So
cube.
the first one? Or the third one?
Well, the third one might get me there, but I need a sine cubed also.
The first
Let's
one.
go to the first.
Yeah, so the first one will get us there easier. Now, they'll all get you there, but the first one will get you there faster. So I'm going to replace cosine 2x with cosine squared x minus sine squared x. Alright, now this is just multiplication. So now I'm just going to multiply. 2 times 2, that gives me 4 sine x cosine x.
It's not pretty, but at least you know I didn't cheat.
Alright, now I'm going to distribute. This is all one term. The 4, the sine, because they all go together. Just one number. This is 2 terms. I'm going to distribute this into both
The whole
terms.
thing.
The whole thing. So, if I distribute it into that first term,
Yeah.
Four sine
Four
x,
sine
cosine
x.
cubed x.
yeah, cosine cubed x minus 4 sine cubed. Now, if you got this far, I would say, bam, you got the answer. The only difference is, look what they did. It's the same
They
thing.
just took the
They
four
just,
out.
they just.
They just.
They factored the 4 out. We have the 4 distributed, and they just factored it out. So it's the same thing. If you got this far, I'd say you get all the credit. But I'll write it like they wrote it, just because.
So you just distributed to the side, like the side of the side of the cosine.
Wait, can you go to the very front page?
Yeah.